I was pretty shocked that ChatGPT got this derivative totally wrong, but by the end of this video, if you stick around, you're not going to make the same mistake. For this derivative, I recommend starting with the inside absolute value. It's going to save you time and you're going to avoid potential traps. So I'm going to call that inner function g of x, and we know that the behavior changes to the left and to the right of x equals 2. And by breaking this up into two intervals like a piecewise, by starting with x is less than 2, if you plug in any value, notice that you'll get a negative result and the absolute value will make it positive. And so what that means is you can drop the absolute value altogether and put this negative in front, simplifying to 2 minus x. Now, when x is greater than 2, the absolute value sign doesn't do anything, so we can just drop it altogether, which means that for g of x, that inner function, its piecewise domain is going to look like this. And you might be wondering, hey, Dave, you forgot x equals 2. Isn't that included? Hold that thought because we might be onto something here. So what I want to do now is take that g of x and plug it in to the original f of x function, both to the left of x equals 2 and to the right of x equals 2. And so from that g of x function above, when x is less than 2, we substitute in 2 minus x into the f of x function itself, and this will simplify to the absolute value of 1 minus x. And now we know that because of g of x's behavior changing at 2, and because this absolute value has behavior changing at 1, I want to work in between the intervals because I want to make sure I catch any possible holes in the domain. So between 1 and 2, once again, try any value and you'll see that the absolute value here is basically taking a negative result and making it positive. So we can drop the absolute value altogether and write it like this, simplifying to x minus 1. And then if I take the derivative of x minus 1, notice that we have positive increasing behavior. So hold that one for a second. Because now when I look outside of the interval to the right for x is greater than 2, which is that next range, x minus 2 minus 1, the absolute value of that is going to be the absolute value of x minus 3 after having plugged in g of x equals x minus 2. And so because we had a behavior change at 2 and this one for the absolute value of x minus 3 has a behavior change at 3, the next open interval we're looking at is between 2 and 3. So plug in any value in that range. You'll see once again we can drop the absolute value and we're making a negative value positive, giving you 3 minus x. And then the derivative of that, check it out, it's actually negative. So the function is decreasing. But before, notice that it was increasing to the left of that point, right? So that tells us that we actually have a hole in the domain of the derivative function at x equals 2 because you go from increasing to decreasing, right? And so that's what ChatGPT got totally wrong, which is actually pretty interesting. So let's summarize so far with f of x. The domain of it is going to be taking the g of x's, right? To the left of 2 and to the right of 2 for x, and we have the absolute value of 1 minus x when x is less than 2, and this down here for x is greater than 2, noticing that we have a hole at x equals 2. And so we need to now break this down further to get our final answer because we still have to deal with that outer absolute value function. So I'm going to start with the absolute value of 1 minus x, looking at when x is less than 2. And by inspection, we know for this absolute value, the behavior changes at x equals 1, right? So we're going to be looking at what's happening around that point. So when x is less than 1, check it out. We can actually drop the absolute value because it's not doing anything. You're just having a positive number. And similarly, when x is greater than 1, we're making a negative positive. So just like before, I can put this negative in front. And now we want to analyze the derivative behavior for these and actually get the derivative value itself because now we want to solve for f prime of x, noticing that the derivative of 1 minus x is negative 1. And then for the other case, it's positive 1. So again, now we have another hole in the domain of f prime of x. We do not have x equals 1 in the domain because we are changing the positivity here. We're going to have jump discontinuity. And so basically to summarize f prime of x, we've partially finished. This is what we have for right now. And what's left to do now for the final step is to now deal with the other absolute value for f of x after we had plugged in for g of x when x was greater than 2, right? So with this one, we have a behavior change at x equals 3. And so for the interval between 2 and 3, we know that if you plug in any value, we're making a negative, a positive here. So again, we can write it like this. And then for the case when x is greater than 3, the absolute value does nothing. And just like before, rinse and repeat, we're going to find the behavior and the values of the derivative functions for each case. And you're going to get these results right here. And check this out. Once again, the positivity around the point x equals 3 changed signs. Another case of jump discontinuity, meaning that for this, in the derivative function, we also have a hole at x equals 3. To put everything together for the final answer, it's going to look like this now.